Alright, so in this video, we're going to talk about properties of parallelograms. So, the property of parallelogram that we're going to talk about first is parallelogram is a quadrilateral with opposite sides being parallel. So by definition, a parallelogram is a quadrilateral with opposite sides parallel. So I can draw that segment BC is parallel to AD, and segment AB is parallel to segment DC. So they're parallel to each other. That's the definition of a parallelogram. There's some properties that exist because that's true. One property is the opposite sides are congruent to each other. It's more of a theorem. So one theorem is, the opposite sides of a parallelogram are congruent. And for that matter, the symbol for parallelogram is this. It's a little slanted box. This is a symbol for parallelogram. That's a long word to be writing over and over, so we draw symbols for it. So if I name the parallelogram above, I would name this parallelogram. We go in clockwise and counterclockwise. So A, B, C, D. That's parallelogram A, B, C, D. So generally I would say clockwise. You might say A, B, C, D, B, C, D, A, and so forth. Another property goes along with it, other than opposite sides being parallel, and the opposite sides being congruent, is the opposite angles are congruent. So another theorem is the opposite angles are congruent, as in they're the same size. And what I mean by opposite angles is angle A, angle C. These two acute angles are opposite angles. They're the same. So no, angle A is congruent to angle C. Angle B and angle D, those two obtuse angles are congruent. So angle B is congruent to angle D. All those are more properties related to parallelograms. I know my opposite angles are congruent because these sides are parallel to each other. If I extended those sides further, I will see this is a transversal over two parallel lines, meaning these two angles are consecutive interior angles. Consecutive interior. Because of that, they're supplementary, because they're formed by parallel lines. For that matter, these two are consecutive interior, as well as these two, because these two are also parallel lines. So any pair of consecutive angles are supplementary. So these two are supplementary, these two are supplementary, these two are supplementary, and these two are supplementary. So another theorem related to parallelograms is the consecutive angles are supplementary. So theorem. Consecutive angles in a parallelogram are supplementary. And I want to make sure you know they're in a parallelogram, because it's only true about quadrilaterals that are parallelogram. So any quadrilateral just won't do. There's quadrilaterals that are also parallelograms. And for that matter, opposite sides are congruent in parallelograms. So I'll draw the symbol this time. All right. There's one more fact about them. All right, so inside this parallelogram, let's make it a parallelogram. So make these sides parallel and these sides parallel. In this parallelogram, the diagonals would connect two opposite angles. So these would be diagonals of the parallelogram. Diagonals bisect each other. The reason why I know this is I know these vertical angles are congruent. I know because these lines are parallel, this angle is congruent to that angle. And for that matter, we know that these opposite sides are congruent because it's parallelogram. So for that reason, angle, side makes angle, side. So these two triangles are congruent triangles making this corresponding part and that corresponding part equal, and this corresponding part and this corresponding part equal. So we can prove that the diagonals split each other in half or bisect each other. So another property is this theorem. The diagonals bisect each other. So those are all the theorems that relate to parallelograms that we can use. Now let's put those theorems to use. All right, so let's find all of the angle measures and side lengths of the parallelogram below. By saying it's a parallelogram, I know these sides are parallel and congruent. I know these sides are parallel and congruent. So I know this side is 7, this side is 7 inches too. If this side is 6, this side is also 6 inches. Also, I know this angle is 70, this one is 70. And if this one's 70, this is 110 because it's supplementary. This is also 110. So now I find all the missing sides, all the missing angles of that parallelogram. Let's look at another one. All right, it says find x and the measure of each angle in the parallelogram. So I know these sides are parallel and these sides are parallel because it says a parallelogram. It told me this angle B is 3x plus 5, and it told me angle C is 3x plus 25. So I know the first angle, 3x plus 5, plus the second angle, 3x plus 25, equals 180. So they're not equal to each other, but they are equal to 180. So when you do the math for it, 6x plus 30 equals 180, and you subtract 30. So 6x equals to 150. Now if you divide by 6, you should get x to be 25. So no, x has to be 25. Now it says find all the angles and x. So I found x. Now I got to find all the angles. So I know x is 25. I know angle B, measure angle B, is currently 3x plus 5. So since I know x is 25, I can rewrite it as 3 times 25 plus 5. So that's 80. 75 plus 5 is 80. So I know that the measure of angle B equals to 80. That's enough for me to find everything else. If I know this angle is 80, I know this angle is 80, I know this angle is 100, I know this angle is 100. So I can find all the angles if I just know one of them in a parallelogram, because all the sides are parallel. All right, let's do a new one. Oh, I'll get that as a note because I'm about to change the screen. So I'll pause the video and copy that as a note. So find the length of AC, segment AC, in parallelogram ABCD. By giving you this symbol, it tells you opposite sides are parallel and congruent. Also tells you that the diagonals bisect each other. So know that this piece is equal to this piece. So an equation you could write would be 3x plus 5 equals to 6x subtract 1. So if that's true, you can solve that equation for x. Give you 5 is equal to 3x subtract 1. Add 1 to both sides. 6 equals to 3x. And we divide by 3. 2 equals to x. So if x is 2, it says find length AC. And I should put a C right here. So length AC would be this length. So it would be 3 times 2 plus 5 equals to AC. So that's 11. So that length is 11. All right, so that's it. I'll get that as a note, and I'm going to go to a new one. So I'm going to pause. You should pause the video and copy the note. All right, so in this new example, it says find the measure of angle D in parallelogram ABDF. So here's angle D. And it didn't tell us anything about angle D. But I do know this though. If I could find angle F, I could find angle D. So because of that, I'm going to find angle F first. And I need an equation. So the equation would be x squared, take away 14, equals to 5x. So to finish solving this is a quadratic equation. So you need to either factor or use quadratic formula. So I can subtract 5x from both sides. I'll get x squared, take away 5x, take away 14 equals 0. And basically this is pretty easy to factor because you're essentially looking for, well, this is x squared, so each one is x here. And you're essentially looking for numbers that multiply to be 14, add to be 5. So numbers multiply to be 14 are 1 and 14, and 2 and 7. So 2 and 7 could add or subtract to be 5. So I'm going to use 2 and 7. To make them become a negative 5, the 7 needs to be negative, and 2 needs to be positive. So my factors are x plus 2, x subtract 7. If you remember factoring, to find the solutions, you set each factor equal to 0. So I would set x plus 2 equals 0, x subtract 7 equal to 0. So one solution is x equals negative 2, and another solution is x equals 7. So if that's true, let's test it. Let's test the negative 2 first. If it was negative 2, that would be 5 times negative 2, which is negative 10. And angles can't be negative, so this is an unreasonable solution. So I can throw out the negative 2, because angles can't be negative numbers. So let's try the 7. 5 times 7 should be 35. So here, it would be 5 times 7, which is 35. And for that matter, that's 35. And if that's 35, this is 180. Take away 35. So that's 145. So angle D has to be 145. So I know the measure of angle D equals 145. All right, let's do one more. All right, it says find PN in that parallelogram. All right, it says find PN in parallelogram PMLK. So by saying it's a parallelogram, I know these sides are parallel, these sides are parallel, these sides are congruent, and I know the diagonals bisect each other. So these parts are equal, and these parts are equal. By knowing the parts are equal, I can make an equation. It'll be 5x plus 8 equals a 10x subtract 12. Pause the video, solve the equation, and see what you come up with. So pause it now and give it a shot. After doing the math, you should have found the x was 4. Because the x we define Pn, which is here, I need to go back and plug in 4. So Pn equals a 5 times 4 plus 8, or 28. So Pn equals 28. All right, that's all I have. Good luck.